what is telling me? Suppose that f is continuous function on the closed interval. That we have closed interval from a to b, a nice and smooth curve. For example, that blue curve. And let n be a number between the values f of a and f of b. That means n is simply a horizontal line between f of a and f of b, where the values of a and b are different. That we can see the values of the corresponding f of n value for a and b, they are different. Then there exists a number c, okay, in that interval from a to b, such that the value at c is exactly n. Okay, that's what you can see. I mean, probably you can read this a few times because we always have to read and digest every single word. But basically what this means, if I have continuous function and if I will draw, if I will pick a number, okay, if I will pick, I think I can start with this way. That's what the theorem is telling. Having a continuous function and drawing a horizontal line just between the values, like line n, right? N, this line will always intersect a curve. And this intersection, the corresponding x, will always fall between a and b. Yes, we can see for this one, we even have 3 intersections. And all of these intersections, all of the corresponding x values will be always placed between a and b. That means basically, this is the intermediate value theorem. Okay? That we will always find the corresponding x value in this. And what we have in mathematics, we do have something like we call existence theorem. And this is actually one of them. Because can you see this? This property, this theorem, it's only telling me that this number exists. Okay, this is telling me, sometimes I don't even have to compute exactly this number. No, I don't have to. I can prove that these numbers like C sub 1, C sub 2, C sub 3, they definitely exist between A and B. And for some of the models, some of the, like the mathematical coding or programming, it will be enough. Yeah, for some engineers, some mathematicians, will be enough. Okay, that means we do have a numbers between A and B. Fine, that's what I need. Okay. Occasionally, if it's the nice easy question, we may still ask you to compute this point C. But normally, we will just prove that this exists. Okay. Now let's see. Of course, if we have discontinuity, it's not true. Because if I can come back here, let's say it will happen that actually exactly at this point I have discontinuity. Then my horizontal line is not even intersecting. Okay, that means of course we're talking about continuous function. Okay. That's the same thing. I'm just looking. Oh, for example, question like that. Show that there is a root of the equation between 1 and 2. Of course, root means solution of this equation. That means I want the value of x that will give me 0. Right? That means it's not easy to figure out, but what we can do, I can name the left-hand side of this equation just as a function, f of x. Okay? Actually, first of all, I should ask you, do you think it's easy to solve this equation? It's the 3rd degree polynomial, and maybe you can try, but I can tell you sometimes it's not easy because it looks like good for grouping, but I don't think the coefficients are helpful. Okay, that we can see it's not easy. It's not easy equation to solve it. Probably the solution exists, but we will need help with some computer. But what I can do, I can only prove that there is, you can see, exists a solution of this equation, and the solution is between 1 and 2. That's what I can do. I can name this equation left-hand side as a function. And I want this function to be 0. Okay? That means horizontal line must be the x-axis, the value 0, n equals to 0. We will do the calculation. That means I don't know how function looks like, but possibly I can draw something, maybe like that, okay? And this is one of the 0, and I want this to be between 1 and 2. Okay? We do have, because they just asking us to prove that one root exists between 1 and 2. Okay? I do have another one, but I don't have to care. I have to find this one. And this is my n value. I think that was kind of like a yellow line. That means I have to prove that this n, the 0, okay, it's definitely will intersect the corresponding x value will be between 1 and 2. That means what we have to do in order to have the function intersect x-axis at here, would be nice to have the corresponding value for 1. This is the corresponding value for 1. Yeah, let's see this situation. And this is the corresponding value for 2. That means, can you see what's happened? One value is above the x-axis, one value is below. Because if we will have, that's actually the guarantee. If we will have the situation, one value above, one value below. Okay, like this is for 1, this is for 2. That's the corresponding values. If the function is continuous function, which this is continuous function, in order to connect them, I have to intersect x-axis. You can see that this is the point to prove that this intersect will exist between 1 and 2. That means what I have to find the value, and I have to find the value for 2. Because 1 and 2, that's the number scale from. And what I'm expecting one value to be positive, one value negative. Because we may also have the situation the other way. Below, 1 and 2. 1 negative, 1 positive. I have to connect them and I will go through x-axis. That's what I want. This will be my 0. This will be my solution, root of my equation. That means let's just do the arithmetic. You have to help me because I have to take this formula and substitute 1 and 2. Do we have some? Okay, that's what's the value for 1? 4 minus 6 plus 3 minus 2. Oh, Daniel, did you answer negative 1? Or maybe that was the old answer. Negative 8. And yes, okay, that means negative 1. Actually, this one works. That means this is below the x-axis, negative. And as soon as this is positive, that's the guarantee. Okay, but who can help me? 4 times 8 minus 6 times 4, it is 12. 3 times 2 minus 2. Oh, this is 32, this is 24, and this will be 4. It's okay, I will not even finish, but this is definitely greater than 0. It is 12? I think it is 12. Good. That means this value is 12. That means, please remember, that's the point. One number negative, one number positive. Could be either way, doesn't matter. Then always we will intersect x-axis and we will meet the value 0. Okay? That means that's definitely the guarantee that the solution of this equation exists between 1 and 2. Okay. So now let's just, shall we finish or shall we solve? This is the solution. Okay, maybe this question. Okay, let's solve this one. This will be the last one because you may see this question. Okay, that means this is the same what we just did. According to the intermediate value theorem, which of the polynomials below must have a real root? Real root means the solution of this equation, okay? Like the value 0, which means which of these polynomials will intersect the x-axis between -1 and 0. Okay, that means what we have to do is a little bit time consuming. But we have to take each polynomial one by one and test the value for -1 and for 0. If one of them is positive, one of them is negative, it will tell me, okay, let's say the value for -1 is negative, the value for 0, it's positive. This is telling me that I will intersect the x-axis, real root, real solution, real x-intercept. That's me. Let's try. You will help me do the arithmetic and we will be finished. That's everything for today. Let's take the first one. Value for -1 and value for 0. For 0 is easy. I can do it. -4. Okay, who can substitute -1? -1, -3, positive, -3, -4. Okay, that's what I see. This is negative and this is negative. Not good. If I have two negatives, that's not a guarantee. Okay, let's test B. Value at -1, value at 0. At 0 is -1. Okay, who can tell me value at -1? -1, it's -2, -3. Oh, I think it's even more than negative. Am I right? Yeah, I think it's actually doesn't matter. All of them are, yes, all of them are negative. That means that's not a guarantee. I am looking for one negative, one positive. Okay, let's check C. F of -1, f of 0. 0 is nice and easy. Okay, -1, +2, -4, -1. I think it's still negative. Oh no. Okay, let's check D. F of -1, f of 0. Oh, f of 0 is +2. I don't have to write plus. Okay, okay, let's say hopefully -1 will give me negative number. -1, +2, -4, +2. Do you think it's negative number? It is. That means this is negative, this is positive. That's what I'm looking for. If I will be on the test, I will still test this one. Okay, because just in case I make the arithmetic mistake. That means this is 5, and this will give me negative, positive, negative, positive. Okay, that means both of them are positive. Also not good. Please remember. Okay, that means that's what we want. We want one value positive, one value negative. Either way. This means that connecting them, I will go through the x-intercept, real root of the equation. Okay, thank you very much for today's session. Thank you.